screen? Can everybody see my screen? Hello?
Yes.
Okay. All right. Better pay attention to this and not be working on your other stuff, or you'll miss some good information. Just saying. Okay, for the exam, there was a wide range of scores from very, very low to almost perfect. So what I've done, I made an announcement on the Canvas page that says, after you receive your results today, and I'm not going to, I wrote some of the answers on your test, but, and I'll do a little bit of explaining, but this is what you can do. After you receive it today in class, you can go to tutoring and rework the problems you missed, then come to my office during my office hours or by appointment no later than a week from today, October 24th. Show me by working through the problem that you understand it and know how to do it, and you can receive half credit for each problem, up to half credit for each problem if done correctly. This must be done by October 24th, and there's no exceptions. Okay? So if you don't do it by then, you stick with the grade you got. All right? Does everybody understand that? So you'll go figure it out. You'll study it a little bit more if you want, and then you'll come and you'll show me how to do the work. I was thinking about having you do it in class, but then the other people will see it, so we'll do it individually, and that you show me. So for now, most people on the written, and that's just for this written portion of the exam, not the questions that were online. So most people got page 1 pretty much. You understood that. Some of you got the directions wrong, like the direction of the arrow. I might have counted off a little for that. But that was pretty simple. That's pretty basic. The second page, I think most of you did a pretty good job. Some of you didn't use all of the quantities. So for instance, on the top one, number 6, to figure that out, you would have had to do the moment for each of those forces and know whether they're positive or negative. So it would have been like the distance times the moment. You start with A on the left, so the first one over would be 5 times 2, whether that's positive or negative, and then the next one would be 8 times 5 feet, because it's 5 feet from A. Whether it's positive or negative, you add or subtract. Then the next one over, the 2K, and then the 3K. And at the bottom, so you got to figure that out if you didn't do it. The bottom one, A is not at the end, but it still works the same way. You know, you might start from the left and figure out which way 4 is going, and then 5, and then 3, and then 2. Okay? The next page, or the next one, number 8 and number 9, all of you got the shear wrong, but I taught it wrong, so I'm giving you credit for that. The maximum shear, no you didn't, I don't think. What did you get minus points on?
On the max shear.
But I didn't, if you look at the amount of points I put up at the top of the page, what did I put?
16. You counted 4 points off.
Well, let me make sure I did. I'll look on the score, because I think I didn't in the computer, I don't think. I did?
Yeah, because I have a 93, and those two and the... I got 3 questions wrong.
Right. Okay, well, when I'm done, come see me and then we'll fix it.
Yeah,
Okay. Okay, I get confused sometimes. It's not hard to do. But when we were going over it the other day, let me explain this maximum shear. Just so, and this is not, I mean, y'all should have gotten credit for it anyway, but I want you to understand it, so it's not something you would redo. So I'm drawing on the screen. You got your, that's the wrong kind of line. Draw it over. Yeah, your baseline, whatever that is, and then you, for instance, on I'm doing number 8. You're going to go up, you know, a quantity of 7K. Damn, why doesn't it be straight? You're going to go up a quantity of 7K, and then you're going to go, most of you got this right, you're going to go over the 4 feet, right? Wherever that is. Then you're going to go down, because you got a force of 6K down, you're going to go down 6. Then you're going to go over 4. And then you're going to go down 9, wherever that is down there. And then you're going to go over here and you're going to go up 8. Well, the other day in the confusion of the review, we were doing actually the maximum moment when we multiplied the areas. The maximum shear is the most shear. So it would be this 8K over here, because that's the most. This one is 7, even though that's longer. And this one's 8. So your maximum shear is wherever the greatest force, the greatest vertical force is. Does that make sense?
And the 9 doesn't count because it's 1 on top and not 8
Right,
on top?
right. So it'd be wherever that happens to be the most. The maximum moment, you know, we got that moment that is the area of,
So that one is 32.
right? Yeah, so that's the 32.
So that little box is 28, or the big box is 28, and the little box is 4.
Right. So this is, that's 28, and this is 4. So then your maximum moment, which occurs at the point of 0 shear, is going to be 32 up here somewhere. Right? Does everybody comprehend that? Say yes. Yes. Or no. Okay, and so in the second one, if you're looking at your diagram, you're going up 26K on number 9. You're going up 26K, then you go over, then you come down a little bit, you go down below 0, and then you go down 36. So your shear, maximum shear is going to be on the right side is 42K, because that's the point where the most
So then
shear.
it would be the bigger of your 2 resultants?
Could be, but I don't think that may not be always. It just happened to be that way in this
The
one.
resultant goes up on one side and down on the other, and then the forces in the middle just kind of make a line.
But if you got into a more complicated beam with more supports or something, it may be different. So, but yeah, in this case, it is the maximum resultant. And then the moment is the over the point of 0 shear, and then the area of the shear diagram. Okay? Then the next page, the truss diagram. This one I probably could have explained better. So I'm not going to give you, I might have wrote the answers. Well, if I didn't, I'll tell you the answers, but I still want, if you missed it, you have to work through it and show it to me. So for the resultants, you do it, you know, the sum of the forces about R1 or R2, and you come up with your resultants. And when you do the forces, you have to include all of them. So for instance, if you're doing R1, you don't, hold on a second. I thought I had it written down here. Okay.
That would include the 100 pounds that's pushing on R2. Then you use the distance from R2 to 200, distance from R2 to the other 200, distance from R2 to the third 200, and the distance from R2 to the last 100 that's pushing on R1.
You said you don't use the one on R2?
Yeah, because that we're using the sum of the moments around R1 is
Mhm.
equal to the sum of the moments around R2, right?
Right.
And you're doing the moments around R2, and the 100 pounds that is pushing on R2 doesn't count because it's a central force.
Right, but
Just like
then,
on, 6 and just like on 6, if there was a force pushing on A, you didn't count it.
right. But so you went 200 times 8, then 200 times 16,
Yep.
then 200 times 24,
Yep.
and then 100 times 32.
Yeah.
Yeah, that's right. You just went the opposite direction than I did. That confused me a second. So you figure out that, and then you get your reactions. You get the R2 or R1 which would be 400, and then you can do adding and subtracting. You add up all the forces going down, which would be 100 plus 200 plus 200 plus 200 plus 100, which is 2, 4, 6, 8, 800, minus the 400 on R1 gives you the 400 on R2. So both of your reactions are 400. Then there's a trick to this triangle business. There's a, I mean, you can do it with sine, cosine, but there's also a rule of thumb for 30, 60, 90 triangles, which I believe is the
1, 2 square root.
yeah, one. It's like, you know, if this, I'm drawing it on here. If this is x, oops, x, then this is 2x, right? Is that right? I thought I wrote it down. Let me look that up real quick.
I think the 1 is on the base, the 2x is on the hypotenuse like you have, but the square root of 3 is on the square root of 3 is on that side.
Okay. I don't know why I didn't write it down on here. Oh, I know where it is. Hold on. Pause 1 second.
Jason is 1/2 square root of 3 over 3, and then the hypotenuse is
So the hypotenuse,
3 is our x. And it has a different answer.
hold on. Let me just start over here. I had
What do
it.
you have in yours? Oh,
I'm gonna draw it again. I had it written down and now I can't find it.
there's 1 on the right, 2 on the top over the hypotenuse, and square root of 3 on the base. I think the way you're doing it is right. Because I'm looking at drawings and they're all saying different things.
Okay, so this is the 30-degree angle right here. This is a 60-degree angle. Of course, this is 90. Now, what did you just say?
1 on the right,
1.
2 on the hypotenuse,
So the hypotenuse is, yeah, that's it.
and square root of 3.
The square root of 3.
Yeah.
Oh, if it's all,
That's what they all have. They're just oriented different.
okay. So then back to the test. If you notice, we got a 30-degree angle on that. So that means all of those angles are going to be 30, 60, or 90. You just got to figure out which one. And then you can remember before when you used like, we knew the height and the horizontal and the vertical distance ratio. So now you can use this ratio, 1 to 2, or 1 for the vertical is a 2 for the hypotenuse, etc. So for joint 1, you have 100 going down, and you got 400 going up, and then you've got, let me draw that for you. You've got your 100 going down. You get that one, and that one. So this is 100, and then this is 400. Then, so the sum of your verticals has to equal 0. So you know that whatever vertical force is in this one is going to be equal to 400, or 400 up minus 300 down is going to be 300. So this will have to be 300, right? Pardon my writing. So now you know that 1 is to 300 as 2 is to the hypotenuse. So it'll be twice that. So it'll be 600. So you know your vertical is, sorry, that was wrong. So now you know that that figure is 600. And then you can figure out the horizontal factor, and then you just move around doing that. And all of those chords will work the same after you can figure out one element or the other. Okay? So that's all I'm going to do for this, unless there's any specific questions right now. Oh, there it is right there. It was on my next page. So if you want to, I'm going to move on to chapter 10, but if you want to receive half credit, then you need to work back through these problems, and some of you really need to do that. And then come and you can either do it in our class before this if you're in here with me, and we can go to my office and do it, or you can make an appointment for another time by next Thursday. Okay? Any questions on the exam? Okay. Now, let's see, I can flip the page. Uh-oh. Damn it. There it is. Okay. Now we're going to talk about chapter 10. So we did, if you have your books, we didn't do we did through 6, so we're skipping retaining walls, rigid frames, and non-coplanar forces. And we're going on to the properties of sections, which is chapter 10, starting on page 181. Okay, so a centroid. You need to know what a centroid is. I wish I could move that thing. A centroid in mathematics and physics is the geometric center of a two-dimensional region. Formally, the point at which the cardboard cutout of the region could be perfectly balanced on the tip of a pencil. The centroid of a plane, figure, or two-dimensional shape is the arithmetic mean average position of all the points of the shape. The definition extends to any object in whatever dimensional space. Its centroid is the mean position of all the points of the coordinate of the system. So it's basically, the balancing point. If you had this triangle and you cut out a cardboard and you put a pencil right there, it should balance perfectly if you're still. And the same, with a rectangle, if you had, a rectangle like that, the centroid is going to be, where the center of it is. And if you, cross lines, then that's the centroid right there. The circle, of course, is in the middle, etc. Does that make sense to everybody? Any questions on the centroid? That's an important fact. Got it? Okay. So the neutral axis. The neutral axis is an axis in the cross section of a beam, a member resting, bending, or shaft along which there is no longitudinal stresses or strains. If the section is symmetric, isotropic, and if it is not curved before the bend occurs, then the neutral axis is at the geometric centroid, usually runs along the same line. All fibers on one side of the neutral axis are in a state of tension, while those on the opposite are in compression. And you can see that in this diagram. This is the neutral axis, which also the centroid aligns with that at some point. When it's resting, it's there. So now when there's force applied to it, all of the fibers in this beam below the neutral axis are in tension because they're being pulled apart. All the fibers above the neutral axis are in compression because, as you can see, the shape of the beam, they're squeezing together. So do you have any questions about that? The definition of a neutral axis. So why do you need to know this? A lot of times you'll need, a lot of these facts and figures are in tables for you to look up, but sometimes there's an occasion where you may need to figure out because it's a different